All right, guys, welcome. It's Mr. Sears, and we're going to do our second lesson of our distance learning experience. So today we're going to be doing a lesson on approximating irrational square roots. All right, so let me pull up this lesson for us, and we'll get going. So first off, our skill for this lesson is approximate. So this word right here, let me remind you what approximate means. Approximating something means that we are getting as close to the actual value as possible, and that's different than estimating, which estimating is usually thought of as making a best guess or an educated guess. Approximating, we're actually going to use a system in order to get as close to the number as possible, or as desired. Now, our concept here is irrational square roots. We're going to talk about that more on the concept page because we'll need some examples to go through that. So again, today we will approximate irrational square roots. I'm going to go through the concept with you, and then Ms. Yamas is going to show you how to do the skill. Okay, let's connect our concept to something we already understand and know, exponents. So right here you see that it says 4 squared. So let me pull up my laser pointer. So here 4 squared, this is the base, this is the power. So 4 squared is telling me to do 4 times 4, 2 of the 4s. Now, I've said 4 squared a few times, and I want to actually connect that to our learning objective. Square roots, 4 squared, there is a connection here. A square root is going to be the opposite of a squared sign. So 4 squared means 4 times 4, which is 16. We're going to take this idea of a square, and we're going to do understand it backwards, looking at it as a square root. So let's go ahead and go to the next page here, and we'll see that our concept says an irrational square root. And here you can see that I've got a 16 here, and I've got a 4, just like we had on this prior page, only it's a little bit different. So let's actually talk about that and go through that. I'm going to start by pre-teaching a couple words here. Irrational. If you don't remember what irrational means, irrational is a non-repeating, non-terminating decimal. That's a decimal that goes on forever without having any patterns. One that we're already familiar with is the number pi. We always have to like round off pi. It goes on forever. We're going to do the same thing with square roots that have decimals that go on forever, and they don't have any patterns. So that's why we have to approximate them. Now, another word that we need to know is radical. So down here, you'll see we have a radical. Now, the word radical, it actually refers to this symbol right here. So this symbol is called the radical symbol. All right, so when I say radical, I mean that actual symbol itself, and then I'll talk about what that symbol tells you to do. Let's go through our concept now, our concept definition. It says an irrational square root. You know what, actually, let's back up. Let's just go a little bit slower and just talk about what a square root is first, and then we'll talk about what irrational square roots are. So a square root is one of the 2 identical factors that multiply together to give the number under the radical. What? Well, if you got that on the first try, nice. But if you didn't, which I wouldn't expect everybody to, because that doesn't make a lot of sense unless we start connecting it to our example. So let's see what that's talking about. A square root is one of the two identical factors. Okay, so I want one of 2, and then identical factors. Okay, so what is a factor? A factor is things we're multiplying together. Okay, so when I look down at my example here, I see that I have this radical symbol with a 16, and then I've got the same thing with 4 times 4, which that equals 16. Okay, I see how this makes sense. And then down below, I see now the square root of 16 is equal to just one number 4, and the radical is gone. Okay, what happened in between these? Let's go back up to this definition and see. An irrational square root is one of the 2 identical factors. Okay, so 4 and 4 are identical. Okay, all right, so a square root is when I see I have 2 identical factors, the numbers that multiply to give me 16, 2 of the exact same ones, I write one of them, and that is the square root. So I would say the square root of 16 is 4. Okay, well now let's go through the whole definition with irrational and look at this example down at the bottom. An irrational square root is one of the 2 identical factors that multiply together. Okay, multiply together, 4 times 4 is 16, okay, to give the number under the radical. Again, 4 times 4 is 16, great. When I look down here at this example, I see square root of 17. And if we pause and think about that, 4 times 4 is 16, and 5 times 5 is 25. So what number times itself an identical factor gives me 17? I have no idea. But here we can see that it says 4.132. It gives us this number. So when I'm talking about an irrational square root, I'm talking about the two decimals that go on forever, that don't have any pattern, that if I multiply that identical decimal together, I get the original number 17 in this case, under the number under the radical. So a square root, an irrational square root, is a decimal that goes on forever, that doesn't have any patterns of repeats. And I want to take just one of those two numbers, and that is going to be my irrational square root. So here I see that the square root of 17 is approximately, that's what this symbol means, is approximately equal to 4.132 ... and it goes on forever. Now you might be asking yourself, where did I get this number from? That is what Ms. Yamas is going to teach you. So checking out from the concept page, let's go on to the skill.
Hey everyone, we're now at the skill development guided practice portion of this lesson. I want to cover all variations with you in order for you to be proficient in this specific lesson. So step number 1, let's simplify the expression if necessary. I have approximate the square root of 14 to the nearest 10th. I'm going to work out the problem and I hope you follow along. If you don't understand a specific step, please pause the video at any time. Rewatch it in order to help you understand it completely. So step number 1, let's approximate the square root of 14 to the nearest 10th. I have here up in the right corner a decimal place chart. My first number behind the decimal point, that is the tenths. I'm going to move my screen so you can see. So the first number behind the decimal is the tenths place. That is what the question is asking me. So I'm going to approximate. I'm going to use step number 2 to identify two perfect squares to help me figure out where this irrational square root falls in between. So in this case, the square root of 14 falls in between the numbers square root of 9 and the square root of 16. So I have the square root of 9 and the square root of 16. The square root of 9 is the number 3, and the square root of 16 is the number 4. Here is my number line that's going to help me figure out where it falls in between. So I know right down the middle I have 3.5. That's the halfway mark between the number 3 and 4. Next, I'm going to figure out where it falls exactly in that number line. So the square root of 14 is only 5 units away from the square root of 9. The square root of 14 is only 2 units away from the square root of 16. So I know it has to be placed somewhere in this section between 3.5 and 4. So I'm going to take a guess and I'm going to work the problem out. I know that if it's 2 units away, I'm going to add 2 units to 3.5, which would leave me with 3.7. I'm going to multiply 3.7 times 3.7, and that leaves me with 13.6. That's really close, actually, to 14 square root. I'm also going to try a couple more in order to see if I can get even closer. And actually, I don't want to go over. So I'm going to try 3.8 times 3.8. And that leaves me with 14.4. At this point, I've gone a little over, so I'm just going to stick with 3.7. That's probably my best estimation or my best approximation. So the square root of 14 is about 3.7. Now, I want you to pause the video, and I want you to try the next one on your own. Approximate the square root of 28 to the nearest 10th. All right, thanks for coming back to me and pausing that video. I want you to look at how I figured this problem out so that you can check your work. So the square root of 28 is in between two perfect squares. That would be the square root of 25 and the square root of 36. So square root of 25 and the square root of 36. 25 would be 5, 36 square root would be 6. So this number has to be in between these two numbers. Halfway point is 5.5. Square root of 28, it's 3 units away from the square root of 25. Square root of 28 is 8 units away from the square root of 36. So the square root of 28 has to be somewhere in between 5 and 5.5. So next, I'm going to figure this out. I'm going to just do a guess and check. I'm going to start off with 5.2 times 5.2, and that leaves me with 27.0, which is kind of close. Then I'm going to try 5.3 times 5.3, and that leaves me with 28.0. And now I'm going to say 9 because it goes to the hundredths place. This one's 27.04. This one's 28.09. I'm going to say for this one that the best bet would be 5.3. So the square root of 28 would be about 5.3. All right, everyone, so now we're at problem number 3 in this lesson. I want to read the problem for you. Approximate the square root of 15 minus 6 plus 18 to the nearest tenth. Now for this problem, we are going to have to simplify this expression because there is more than one number underneath that square root. So I have the square root of 15 minus 6 is 9. Now I have 9 plus 18. The square root of 9 plus 18 leaves me with 27. So I've simplified the expression. Now I can identify the two perfect squares that this square root falls in between. So the square root of 27 is in between the square root of 25 and 36. So next, I know that the square root of 25 is 5 and the square root of 36 is 6. I'm going to draw my number line. Right down the middle, I have 5.5. So with a different color. Now, what helps me figure out where it falls in between each section is counting the units. So the square root of 27 is 2 units from 25, square root. The square root of 27 is a total of 9 units from the square root of 36. So I know because it's closer to the square root of 25, it has to fall somewhere in this section. So I'm going to start off and say that 5.2. 5.2 times 5.2 leaves me with 27.04, which is really close to the whole number inside the square root, which is 27. So for this one, it happened to work out. So I'm going to say that the approximation of the square root of 27 is about 5.2. Now I want you to pause the video, try the next one. So let me read this for you. Approximate the square root of 27, the square root of 27 minus 4 plus 15. We're going to finish off the problem by simplifying the expression if necessary, identifying if the two perfect squares fall in between there. We're going to estimate the decimal points to its approximation. Next, we're going to use the square root approximation to determine if it is close to the original number. Then we're going to repeat steps 3 and 4 until the approximation best represents the square root. So go ahead and pause the video now. All right, guys, thanks for pausing the video and coming back to me. Let's go ahead and figure out this next problem. So I have approximate the square root of 27 minus 4 plus 15. Let's simplify that expression. 27 minus 4 is 23. 23 plus 15, and make sure this is all underneath that square root sign, would happen to be 38. So now I have to figure out what is the approximation to the square root of 38. And I need to make sure that I use my perfect squares to help me figure this out. So the square root of 38 falls in between the square root of 36 and the square root of 49. So the square root of 36 is 6 and the square root of 49 is 7. So somewhere in between these two numbers, and right down the middle I have 6.5, I know that the square root of 38 falls in between. So 36 is only 2 units away from the square root of 38. And square root 38 is 9 units away from the square root of 49. Because it's closer to 38, it's closer to the square root of 36, I know it has to fall somewhere in between 6 and 6.5. So I'm going to start off with 6.1. I'm going to multiply 6.1 times 6. Excuse me, guys. I'm actually going to fix that. Let me find my eraser option. Write it nice and neat for you guys. All right, so let's go ahead and start off with 6.1 times 6.1, and that leaves me with 37.2. Now that's super close to 38, but I want to see if I can go closer without going over. So I'm going to start off with next 6.2 times 6.2, and that leaves me with 38.4. Now I did go over a little bit, but not too much. But for this one, I'm going to say the best approximation would be 6.1. So the approximation of the square root of 38, or the square root of 27 minus 4 plus 15, would be about 6.1. All right, guys, so we're on the last set of problems. Notice that we have a little bit more complicated problems this time around. We're going to approximate the square root of 12 plus the square root of 42 to the nearest whole number. These two square roots are two separate approximations that we're going to have to do. So let's simplify the expression. We don't need to do it. However, we need to identify the square root of 12 and the square root of 42 between two perfect squares. We're going to estimate a decimal approximation for the square roots, and then we're also going to approximate and determine if it is close enough to the original number. So up here on my screen, I have the square root of 12, and I have the square root of 42. These are two separate irrational square roots that I'm going to do. At the very end, I am going to add the sum or the approximations together. So the square root of 12 is in between the square root of 9 and the square root of 16. The square root of 9 is 3. The square root of 16 is 4. I'm going to draw my number line. Right down the middle, I have the square root of 9 and 16, 3 and 4. Halfway down is 3.5. I'm going to use the units in between to figure out what section it lies or it falls in. So the square root of 9 is only 3 units away from the square root of 12. The square root of 12 is only 4 units away from the square root of 16. So I know it's kind of down the middle. So I'm going to start off with 3.5. 3.5 times 3.5. Now, 3 and 4 is really close together, so that's why I started down with 3.5. I'm going to multiply those two parts, and I have 3.5 times 3.5 is about 12.2. That's really close to my original number, which is the square root of 12. But just for clarification, I'm going to try 3.4 times 3.4, and that leaves me with 11.5. Yeah, that kind of doesn't really work because I have 12 is really closer to 12. So we're going to stick to 3.5. So the square root of 12 is about 3.5. My next one. I have the square root of 42, and I'm just going to kind of show you guys. I'm going to add these two parts. The square root of 42, and I'm going to break it apart. The square root of 42 is in between the square root of 36 and the square root of 49. So it happens to be in between 6 and 7. And draw my number line. Halfway point is 6.5. So I know that 42 square root is only 6 units away from the square root of 36. Then I have the square root of 42 is only 7 units away from the square root of 49. Again, we kind of see that it's the same amount, give or take 1. So I'm going to go right down the middle. Has to be somewhere in this section here. So let's try 6.5 times 6.5. That leaves me with 42.2. That's actually really close to the original number of 42. So I'm going to say my approximation for the square root of 42 is about 6.5. Right, ladies and gentlemen, we've done both parts. I have 3.5 plus 6.5, and I'm going to show you the work now that we've done the approximations. So 3.5 plus 6.5 leaves me with a total of 10. So I know that the square root of 12 plus the square root of 42, round to the nearest whole number, is about 10. I'm going to actually draw this in black so you guys can see. Now I want you to pause the video and try the next one on your own. Approximate the square root of 20 plus the square root of 56 to the nearest whole number. All right, everyone, I'm going to have you self-check. I'm going to work out the problem. Please follow along to check if your answer is correct. So I have the square root of 20 plus the square root of 56. These are two separate square roots that I'm going to have to do an approximation for. So the square root of 20, the square root of 56. I will add up the sums at the very end. Square root of 20 falls in between 16 square root and 25 square root. So square root of 16 is 4, and the square root of 25 is 5. Right down the middle, I have 4.5. I know that the square root of 16 is only 4 units away from the square root of 20, and 20 is 5 units away from the square root of 25. So because it's about the same amount on each side, I know I'm going to just kind of start down the middle. So I have 4.5 times 4.5, excuse me guys, and that leaves me with 20.2. Actually, it's really close, and we went over just by 2, but not by much. So I'm going to stick with 4.5. So the square root of 45, I'm going to put my plus sign so you guys can see it's about 4.5. Okay, my next problem. I'm going to actually move it so you guys can see. I have the square root of 56. So the square root of 56 falls in between two perfect squares. It would be the square root of 49 and the square root of 64. I'm sorry, guys, it's a little bit sloppy. I'm going to try my best to stay clear and organized as possible. And actually, I'm going to rewrite this because I want everyone to see. Square root of 49 and the square root of 64. I'm going to draw this out. I know the square root of 49 is 7 and the square root of 64 is 8. Draw my number line right down the middle. I have 7.5. I know that 56 square root is only 7 units away from square root of 49, and the square root of 56 is 8 units away from the square root of 64. So because, again, it's like similar down the middle, and when I mean similar, I mean it's only off by 1, so it's not a huge gap difference. So now I'm going to try 7.5 times 7.5, which leaves me with a total of 56.2, and I'm left really close to the original number. So 56 is really close to square root of 56. So now I have the approximation of 56, and I'm going to put my approximation sign. Here is about 7.5. And this one I have over here in this section. So now we're going to add those two parts together. So I have 4.5 plus 7.5. That leaves me with a total of 12. So if you got 12, you're on the right track. If you made an error along the way, please re-watch the videos, work out the problems again to further your understanding of approximation or approximating square roots.